good evening, because I'm guessing you're watching this on Friday night. And this is your Friday night homework video. I'm sorry I'm giving you homework on a Friday, but the reasoning is I'm trying to make sure that you do your unit test before review week, which is just after next week. So if all goes according to plan, you'll be doing your unit test on Friday, but if not, then it's on Tuesday, the week of review. Just a tip before I go into this is a lot of you are saying that in the videos you just watch what I do and then you write down what I write down. Sometimes you're not even listening. So since this video is kind of replacing that in classroom learning, I really urge you to put some effort into trying to understand what's going on, because that's what helps you to go on and do it on your own. I encourage you to pause. You know, it doesn't hurt you to pause. Take a pause and then see if you can figure out the question before I do it, and or if you can fill out the whole thing and then just skip forward to see if you're right, instead of just writing down everything that I write down. That will help you learn better. Alright, let's start with this example. Using the change of base formula, evaluate each expression as a quotient of natural logs. Use a calculator to approximate each to 5 decimal places. Alright, change of base formula says, this is what we had here, that if I have the logarithm of logarithm of m to the base b, I can introduce a common base to both the power and the base, right? I can introduce a base n to the power and a base n to the base b, which can just be logarithm of that base to the power, logarithm of that base to the power of the base. That common logarithm that I introduced can also be the natural logarithm. So, and this is going to be a simpler one to use all the time. Just introduce natural logarithm to the power and natural logarithm to the base. So if I try to do that here, I'll introduce a natural logarithm to the power, which is natural log 65, divided by natural logarithm of the base, which is natural log 8, and then you can just use a calculator to divide that, and that will give you the answer right away. This is the example we did in your textbooks yesterday. Same thing here. The power is 15 out of 4, so you introduce natural log to the power, 15 out of 2, which is natural log 15 out of 2 divided by natural log 2. Natural log 15 out of 2 is the same as natural log 7.5 divided by natural log 2. Put that in your calculator, and then you have an estimate for what the answer is. That's the change of base. It can be useful in certain questions, and in this lesson we'll just be talking about different ways that we can solve algebraic equations, would you believe it? Algebraic equations using logarithms. So in this equation, because the bases are the same, I can just go ahead and equate the powers. X minus 1 is equal to 2x minus 4. Now at this point, this is where I encourage you. You can pause, do this thing on your own, see if the answer you get at the end is the same answer that you expect to get. Alright, so collecting like terms, I'm going to take this positive x to the right, and I'm going to take this negative 4 to the left. So I'll have negative 4 crosses over this way will be positive, so 4 minus 1, and then 2x minus x because the positive x crosses. So I'll end up with 3 is equal to x, right? Another question is here. Solve a to the x plus 2 is equal to 16x to the x plus 1. Now, 8 and 16, the bases are not the same, so I cannot equate the powers. But 8 and 16 can both be written in terms of powers of 2, right? Because 8 is 2 to the power 3, and 16 is, this will be 2 to the power 3, but there's a power of x plus 2 on the top, and 16 is the same as 2 to the power 4, and there's a power of x plus 1 on the top. Again, you can pause here, do it, and see if we'll come to the same answer. This, when you have this scenario according to indices, you just multiply the powers, so that will be 3 into x plus 2, and this will be 4 into x plus 1. This is 2, 3x plus 6 equals to 4x plus 4. Since the bases are the same, I can equate the powers. 3x plus 6 must equal 4x plus 4. And just in case you're wondering, why do we always equate the powers? Well, if 2 to the power 2 is equal to 2 to the power 2, that means for these things to be equal, I have to raise those bases to the same power, right? So if this was x and this was y, then since the bases are equal, those two have to be the same. X has to be equal to y. Okay, so solving what I have done here, 3x plus 6 is equal to 4x plus 4. I'm going to take away 3x. This is the Zoe method. Take away 3x. Then you have 6 is equal to x plus 4. Then you take away 4. Then you take away 4. Then you have x is equal to 2. Alright, but I encourage you at this stage, you should be able to get from here, right, from this stage and jump to this, right? In your head, you should see that 4x minus 3x is just x, and 6 minus 4 is just 2. This is going to, these are some of the skills that are going to help you save time now in calculus and even further when you're doing math onwards. Another one is here, 3 to the x plus 1 is equal to negative 2. 3 to the x plus 1 is equal to negative 2. Now I'm trying to figure out what power do I raise, what value of x, such that when I add 1 to it and then raise 3 to that value, I get a negative 2. I hope you remember clearly that we talked about, when we were talking about exponential functions, there is no possible value of x that you can raise any number to get a negative. There is no possible power. There is no, it's not possible to raise any number to any value and then the answer comes out as a negative, right? That's just not practically possible. So since that's not practically possible, I can just stop and say this equation has no solutions, right? This equation has no solutions. And what that means in a graphical context, what that means is that if I graphed that equation, it would not cross the x-axis, right? This line y equals 2 is over this way. That's the line y is equal to 2. And it's very far away from the x-axis because this is the x-axis. And this graph doesn't even cross the x-axis, right? Or if I was trying to use the idea that if these are equal, then when I graph y equals 2 and also graph y equals 3 to the x plus 1, where they intersect is the solution. When I graph 3 to the x plus 1, I hope you remember exponential functions. It's going to look something like this, move one point to the left, so something like that, right? This function and this function, and this is not on the same dot, I just drew it dotted. Those two functions do not meet. Since they not meet and they will never meet, there is no solution to this equation. So just the learning point here is that, and just to emphasize, there is no value to which you can raise any base and come out with a negative number, right? There's just no value. If you ever encounter this situation, then there is no solutions. All right, 5 to the x plus 2 equals 4 to the x. 5 and 4 cannot be expressed in terms of the same base. So every time you encounter this problem, your friend natural logarithm can always bail you out. How do we use the natural logarithm? I can introduce the natural logarithm to both sides of the equation. So I can introduce natural logarithm to the left-hand side, and I can introduce natural logarithm to the right-hand side. And then I use the power rule. I know that when I have a power, that power drops to the front. That power drops to the front. So down here I'll have x plus 2 times natural log of 5 is equal to x times natural log of 4. Now I have a simple equation which just has normal variables and normal unknowns. X times natural log of 2 is just, times natural log of 5 is just x natural log of 5. 2 times natural log of 2 is something I can get on a calculator. 2 times natural log of 5 is equal to x times natural log of 4. So x natural log of 4 and x natural log of 5 and x natural log of 4 are common terms which I can collect. I can collect like terms. I'm going to subtract x natural log 4 this side and subtract x natural log 4, and then I'll have I'll have x natural log 5 minus x natural log 4 is equal to, since I want to get just x on its side, I'm going to move this whole thing to the other side, to this side, and it will be negative 2 natural log 5. Honestly, I'm just being fancy with this, but if you just plug your calculator values in here and then write your answer, I mean your values for the small places, you can still solve from that stage onwards with digits. But I'm keeping the natural logs in till the end because I just like to have a very aesthetic solution. So natural log 5 minus natural log 4 is equal to negative 2 natural log 5. Here, still, like I said, just being fancy, I can see that natural log 5 minus natural log 4 is the same thing as natural log 5 divided by 4. If you remember the quotient rule or property of logarithms, equals negative 2 natural log 5. And my final x value will be, if I divide, because I'm dividing both sides by natural log 5 over 4, and divide this side by natural log 5 over 4. So x will be equal to minus 2 natural log of 5 divided by natural log of 5 divided by 4. I can leave my answer like this, or I can go ahead and substitute all of this in a calculator and get one single value. Like I said, at some point, you have the right at this point, right here at this very point, to plug in the calculator natural log of 5, get a decimal number, put it here for something, and I'm just making this up, so don't quote me on this. Put in this as well, and then just solve from there. Just solve like any other normal algebraic equation from there. What I'm doing here is just trying to be cool. Yeah, so you can plug this in your calculator and you get an answer which will be very, very accurate compared to this, which is still accurate, but yeah. Solve this 100 equals 20 e to the power t. Every time you see an equation like this, you see an e to the power t, you know you're going to have to get rid of that e to the power 2t. And the only way to get rid of that is to introduce a natural logarithm. So first steps first, I need to get rid of the 20. I'm going to do that by dividing both sides by 20, divide by 20, divide by 20. So I'll have 5 here equals e to the power 2t. I want that power to come down, and the only way for that power to come down is if there's a logarithm here, right? So what I'm going to do is to introduce natural logarithm on both sides of this equation. I'm going to introduce a natural logarithm and a natural logarithm. That natural logarithm will cause this power to come down, and when it comes down, I can solve for it. So I have natural logarithm of 5 equals 2t natural logarithm of e, which remember is just 1, because natural logarithm of e is 1, because logarithm of e is just 1, right? So natural log of 5 is equal to 2t. That means t is equal to natural log 5 divided by 2. Plug that into your calculator and get the final answer to 4 decimal places. Have another one here. 4e to the 2x plus 5 is equal to 12. So again, I'm trying to isolate this term. I'm trying to isolate this term 4e to the 2x. And I'm going to do that by subtract 5, so that's equal 7, right? After equating that to 7, I'm going to divide by 4 both sides, divide by 4. I have e to the 2x is equal to 7 out of 4 with, 7 out of 4. To get rid of the e, I need this part to drop down so I can solve for the x. So I'm going to introduce a natural log on both sides. When I introduce a natural log on both sides, this will be 2x natural log e is equal to natural log 7 out of 4. So the natural log e cancels because it's 1. It just becomes 1. So yeah. Then 2x is equal to natural log 7 out of 4. If I want to find x, divide by 2 both sides, and then I'll end up with x equals natural log 7 out of 4 divided by 2. Again, you can put this in your calculator to find the final answer. Another one, solve this. Already I can see, since I have logarithm of 2 to the power 2, I know that's already 1. Laws of properties of logarithms. Logarithm of 2, 3x minus 5. Okay, I can simply simplify that. So I'm going to work around to see how I can isolate that x is equal to 3. See, this is a 1, this is a 3. I can take away 1 both sides. Then I'm left with the logarithm of 3x minus 5 base 2 is equal to 3 minus 1 is a 2. Now I have something that I can solve simply because I can use the cycle. The 2 to the power 2 must equal 3x minus 5. So 3x minus 5 must equal 2 to the power 2. 3x minus 5 equals 2 to the power 2 is 4. Add 5 both sides. 3x equals 9. Divide by 3. And then x is equal to 3. Right? 2 natural log x plus 3 is equal to 7. Same thing. Take away 3 from both sides. So you're left with 2 natural log x is equal to 4. It's a very, very healthy x. 2 natural log x equals 4. Divide by 2 both sides. Then you have natural log x is equal to 2. So how do you get rid of this? Now, quick step is to just introduce an exponent to both sides. If you introduce an exponent to both sides, it will get rid of the natural log for you because they're inverse functions. Then you just end up with x equals e to the power 2, which e to the power 2 is just 2.718 something to the power 2, which is something you can solve. But for some reason, this step here causes a lot of scratching for people. So let me just try to explain it differently. We had natural log x equals 2, right? Remember, natural log is simply the same thing as logarithm to the base e, the natural number e. The base of that logarithm is the natural number e, but it's just written as natural log in, just so we don't have to write log e each time, is equal to x is equal to 2. And if it's written in that form, then you can simply see that the e to the squared is equal to 2, which can simply be written as e to the power 2 is equal to x, is equal to x. So x equals e to the power 2, which is the same answer as we have here. So to just, because all of this is known, but just to simplify it and to not want to go through this every time, when you have natural log of x equals 2, you know mentally that when I introduce an exponent as a base on both sides, exponent to the power natural log are inverse functions, so I'll just end up with x equals e squared. So again, you can put that in your calc and get the final answer. Another one, natural log x squared equals natural log 2x plus 3. So since I see natural log both sides, and only because I see natural log and then parentheses inside the variables, right? Only because I see that. This doesn't work if I have like a 3 here. Since I see natural log both sides, I can just cancel out the natural logs, right? I can just cancel out the natural logs. Same thing as if you had square root of 4 equals square root of x, you could just cancel out the square root both sides. However, a more mathematical explanation would be to introduce the exponent, the natural number on both sides. Introduce the natural number as a base on both sides, and that cancels out the natural log for you nicely. So you have x squared is equal to 2x plus 1 plus 3, quadratic equation, x squared minus 2x minus 3 equals 0. If I factorize this, I think it's x minus 1, x plus 3 equals 0, and no, it's not. It's minus 3 and plus 1. Minus 3 and plus 1 equals 0. So that means that x is equal to negative 1, or x is equal to 3. Those are my two values of x equals -1 and x equals 3, positive 3. Another one, e to the power 2x minus e to the power x is equal to 56. Now, e to the power 2x is the same thing, and I'm only seeing this because I see e to the power x here. And some of these questions, you will only get used to doing them when you do them a couple of times. So, I see e to the power x here. I see e to the power 2x. I see a squared element here. So I can try to express this as a squared element and try to form a quadratic equation. What do I mean? E to the power 2x is the same thing as e to the power x squared, or power 2, right? And I already have an e to the power x here equals 56. So I have a quadratic equation in terms of e. What do I mean? If I replace this e by some more realistic thing, if I just say let p equals e to the power x, right? Everywhere I see e to the power x, I'll get another letter like s, right? S is e to the power x, right? So this will be s squared minus s equals 56. As a quadratic equation, s squared, s is a bad letter. I was thinking of short. Let's try another letter, can be m squared minus m equals 56. So where you see m, it's just standing for e to the power x. This whole thing, e to the power x, I'm just replacing it with an m, just so I can work with this in an easier format for me to understand. As a quadratic equation, this is m squared minus m minus 56 is equal to 0. I think the factors for these are 7 and 8. Yeah, 7 and 8. So it will be m minus 7, m plus 8 equals 0. But if this is negative, the 8 has to be negative. Alright, m minus 8 is equal to 0. You can do the factorization on your own. So if m plus 7 and m minus 8 is 0, that means m equals -7 or m equals positive 8. Now remember, I simply introduced the m for convenience, right? It wasn't part of the initial question. I just put it there for convenience. What was part of the question was e to the power x, and I know that my e to the power x is m, and that m is either -7 or 8. So what happens when e to the power x is -7? Well, remember, there is nothing, no value of x that you can put as a power to get a negative number. So this whole result is just discarded because it's impossible to get a logarithm of a negative number. What if e to the power x is equal to 8? How do I solve for x? I can do that by introducing, I want the power to drop down, so I can introduce a natural log on both sides. Natural log on both sides. So this will be x natural log e equals natural log 8. Natural log e is just 1, so x is equal to natural log 8 is my answer, which you can plug in your calculator to get 0. Going back to this, if I had stuck to my guns and said, well, e to the power x is -7, introduce natural log both sides, introduce natural log both sides, well, I would still end up having to figure out what the natural log of -7 is, and my calculator will tell me that that's an error because it's undefined, because there is no number that you can raise. There's no possible number that you can, possible positive number that you can raise to whatever power you want to get a negative number. So that's just the reason. Alright, this homework, hopefully we can go over it in class on Monday, right? This homework here. If you have questions, if you have any other questions on previous homework or these very videos, then class on Monday. If you have questions, please send a comment or an email.